there, my name is Tawfiq Omar Uthman. In our lesson 4, chapter 3, lesson 4, we take rats of change. And there is a link for exercise of this lesson below the video in the description. You can use it. Let us start our lesson. Rats of change. We have seen how the derivative is used to determine the slope. The derivative can be used to determine the rates of change of one variable with respect to other. A common use of rates of change is describe the movement of object in a straight line. It is customary used the either horizontal or vertical line. Rates of change is derivation with respect to the time. That means taking derivative respected to the t, f of t over dt. Horizontal motion. When the body moves in a straight line, horizontal movement from left to the right, it is a positive direction and moving forward, so that this distance and velocity and acceleration are positive. That means when movement is from left to the right, it is a positive direction, and each of distance, velocity, acceleration are positive, must be positive. But if the movement was from right to the left, it is a negative direction and moving backward, so that distance, velocity, and acceleration are negative. St is a function gives a position of the object relative to the original as a function of t is called position function. And average velocity is equal VAV, which is equal change in position over change in time. That means st2 minus st1 over t2 minus t1. When t1 is the start time and t2 is the end time, where st1 is the start position and st2 is an end position. Average of acceleration is change in velocity over change in time. That means vt2 minus vt1 over t2 minus t1, when v1 is the start velocity and vt2 is the end velocity. St is called a position function, and vt is equal s prime t, it's called a velocity function, the instantaneous velocity. And at is equal v prime t, which equal s double prime t, is called acceleration function, the instantaneous acceleration. A point moves on the x-axis. The function st, which equal t squared minus 5t plus 4, is the position function of the point. T is measured in a second and s in meters. Find the average velocity of this point during the first 2 seconds. Then find the instantaneous velocity at t2. It says that at the first 2 seconds, that means t1 is 0 and the last time is t2, which is equal to. Then VIV, average velocity, is equal st2 minus st1 over t2 minus t1, which equal s of t2 is 2 minus s of 0, which is t1 over 2 minus 0. And now replacing 2 in place of t in the position function, which become t square, it become 2 square minus 5 times 2 plus 4 minus, after that replace 0 in this here, it become 0 square minus 5 times 0 plus 4 over 2 minus 0 is 2. 2 square is 4, 5 times 2 is 10 plus 4, that means minus 4 minus time positive is minus 4. Simplifying, it become minus 3 meter over second. This is the average of velocity. That means the point moves backward 3 meter over second. Vt, which is instantaneous velocity, is equal s prime of t. Then Vt is equal, take the derivative of this function. Derivative of t square is 2t minus derivative of 5t is 5 plus derivative of 4 is 0. And now at t, this is a velocity at any point. We want at t is equal to 2. Therefore, if v of t is equal to 2 times 2 minus 5, that means Vt is equal minus 1, which means the point moves backward 1 meter over second. Note that the velocity we calculated is not only the speed of the point, but it also indicated direction. Check it out. What is the average velocity of the point during the period from t1 3 to t2 7? What was the instantaneous velocity at t equal 5? The position function is t square minus 5t plus 4. t1 is 3 and t2 is 7, and average is equal st2 minus st1 over t2 over t1, then s7 minus s3 over 7 minus 3, replacing 7 in the position function, it becomes 7 square minus 5 times 7 plus 4 minus 3 square minus 5 times 3 plus 4. 7 square is 49 and 5 times 7 is 35 plus 4 minus 3 square is 9 minus time minus is plus, then 5 times 3 is 50, then minus 4. Simplifying is 5 meter over second. This Average is mean that the point moves to the positive direction 5 meters in the second. To find instantaneous, take the derivative of the function. The derivative of this function is 2t minus 5, and then replace t equal to 5, become 2 times 5 minus 5, which equal 5 meters over second. That means the instantaneous the velocity. Example number 2. A point move on the x-axis. The function st is equal to t squared minus 5t plus 4 is the position function of this point. T is measured in the second and s in meters. Find the acceleration of this point at t equal 5. To take to find the acceleration, we can take first of all, we must find the velocity. Velocity is equal s prime of t, then ft is equal to t minus 5, then at is equal the derivative of velocity, which equal 2 meter over second square. At t is equal 5, then a5 is equal 2 meter over second square. As you can see here, an acceleration is a constant. What is the average acceleration of the point between the two instants t equal 3 and t equal 7? St is equal to t squared minus 5t plus 4. First of all, find the velocity, which velocity is equal to the derivative of position function. The position of t squared is 2t minus derivative of 5t is 5. Then AV is equal v2 minus T1 over T2 minus T1. Then at T1 is 3 and T2 is 7. Therefore, AIV is equal V7 minus V3 over 7 minus 3. Replacing 7 in velocity, then 2 times 7 minus 5 minus 2 times 3 minus 5. Simplifying it, AIV is equal 8 over 4, which equal 2 meter over second square. An average of acceleration. Vertical motion. The position function represents the height of the body from the ground, supposing that it is moving on vertical line projected upward. If the movement was from ground to the upward, that means the positive direction and moving higher. Therefore, distance, velocity, and acceleration are positive. But if the movement was from upward to the down, then it is a negative direction and moving lower. Therefore, distance, velocity, acceleration are negative. In the highest point, be careful, in the highest point, Vt is equal 0. That means the velocity is 0 because the point or the body will stop for. Model of the vertical motion. If the movement or the distance unit is meter and the velocity unit be meter over second, and the value of g, which means the acceleration is 9.8 meters second square, then the model be st is equal minus 4.9 t square plus v naught t plus s naught. But if the unit of distance is feet, therefore the unit of velocity be ft over s, and the g be 32 feet second square, and st, the position function, be minus 16 t square plus v naught t plus s naught. That means if the unit was meter, we can use this model, and if the unit was feet, we can use this model. Check it out. In a firework festival, a rocket is launched upward from the height of 2.5 meters of the ground at an initial velocity of 49 meters over second. Write the position function for this motion of the rocket. That means 2.5 is s naught and 49 meters over second is v naught. And because our unit is meter, therefore we can use the st is equal minus 4.9 t square plus v naught t plus s naught. And now replace in place of s naught 2.5 and in place of v naught 49 meters over second. That means st is become minus 4.9 t square plus 49 t plus 2.5. This is the position function. What is the highest point this rocket can reach? And the highest point of when this rocket reach is v naught, or the velocity is equal to 0. Therefore, we must find the velocity first of all, then the velocity is equal the derivative of the position function. It become 2 times 4.9 is 9.8 t plus v naught. And now, because at the highest point the velocity is 0, therefore the minus 9.8 t plus 49 is equal to 0, and take 49 from left to the right, become minus 49, divided both sides by minus 9.8, then t is equal 5 seconds. That means after 5 seconds the rocket reached the highest point. And now we want to find the highest point, not the time. Therefore, we must find the distance. That means replace 5 in the st, the position function. That means s5 is minus 4.95 square plus 49 times 5 plus 2.5. It becomes s5 is equal 127.5 meters. The highest point which the rocket reached. Check it out. C. What is the velocity of the rocket when it reaches 120 meters upward and then 120 meters downward? When the rocket reaches the 120, that means st is 120. and that means that minus 4.9 t squared plus 49t plus 2.5 is equal 120. By taking 120 from right to the left and simplified, it becomes t squared minus 10t plus 24 is equal to 0. And now factoring, it becomes t minus 4, t minus 6 is equal 0. When t is equal to 4, therefore t is equal 4, that means the rocket will reach upward to the 120 meter after 4 seconds. And when t minus 6 is equal to 0, then t is equal 6. That means when the rocket reach to the 120 downward after 6 seconds. To find the velocity, take the derivative of this function. The derivative of minus 4.9 t squared is minus 9.8t, and the derivative of 49t is 49. When t is equal to the 4, then v of 4 is equal minus 9.8 times 4 plus 49, then v4 is equal 9.8 meter over second. It was the velocity upward. And when t is equal to 6, then v6 is equal minus 9.8 times 6 plus 49. That means v6 is equal minus 9.8 meter over second, the velocity downward. This minus, that means the rocket going down road from up to the down. D. What is the acceleration of the rocket at each instance? Vt is equal minus 9.8t plus 49. Take the derivative. At is equal v prime of t is equal minus 9.8 meter over second acceleration of the rocket at each stand time. E. When will the rocket reach the ground? When the rocket reaches the ground, that means the distance is 0. That means the st is 0. As you can see here, the distance is 0. Therefore, take the distance and equal it to the 0. Therefore, minus 4.9 t squared plus 49t plus 22.5 is equal 0. Dividing by minus 4.9, then t squared plus 10t plus 0.51 equal to 0. Solving this by using rule, t is equal minus b plus minus square root of b square minus 4 ac over 2a, and it gives us two value of t. One of them is minus. We cannot take it because never t be negative. Then after 10 seconds, the rocket will reach a ground. First of all, draw a picture and name the variables and constants. Use t for time. Second, write down the numerical information the given. Write down what you are asked find That means find the required. Write an equation that related variables and constants. Differentiate with respect to the t and evaluate it. Use the known values to find the unknown. Question number 1. A rectangle has a length 2t plus 1 and wide square root of t. Find the rates of change in the area of the rectangle when t is varies. Solution: the area of rectangle is wide times length. That means square root of t times 2t plus 1. And taking the derivative respected to t, then dA over dt is equal. The first one, this is the multiply of two functions. Therefore, the first square root of t times the derivative of the second, which is 2, plus the second, which is 2t plus 1, times the derivative of the first one. The derivative of square root of t is 1 over 2t. And now, by simplifying, then dA is over dt is equal 4t plus 2t plus 1 over 2t, 2 square root of t. Then dA over dt is equal 6t plus 1 over 2 square root of t. As you can see that the C is a correct answer. Assume that x and y are two differentiable functions at a variable t. If y is equal square root of x and dx over dt is equal 3, find dy over dt at x equal to the 4. First of all, we have a function or the equation y is equal square root of x. Take the derivative respected to t. Therefore, dy over dt is equal the square root. The derivative of square root of x is 1 over 2 square root of x times dx over dt. Every time you take the derivative of y respected to t, multiplied it by dy over dt. And when we take the derivative of x respect to the t, we multiply it by dx over dt. When x is equal 4 and dx over dt is equal 3, therefore dy over dt is equal 1 over 2 square root of 4, because x is 4 and dx over dt is 3. Therefore 3 times 1 is 3. 2 times square root of 4 is 2. 2 times 2 is 4. That means dy over dt is equal 3 over 4. That means B is a correct answer. The area of the triangle is A, which equal 1 over 2s squared cosine theta. If the theta increasing by 1 over 2 radian per second, find the rates of change in the area of the triangle at theta is equal pi over 6. We have an area equation. Area is equal 1 over 2 s squared sine theta. Take the derivative respected to t. Then the derivative of I is d of I over dt, which equal, this is constant and this is constant, right, same. Then the derivative of sine theta is cosine theta. Because theta is a variable, then we multiply d theta over dt. And now replacing, theta is pi over 6 and d theta over dt is 1 over 2 radian. Therefore, dA over dt is equal 1 over 2 s square cosine pi over 6 times 1 over 2. 1 over 2 times 1 over 2 is 1 over 4 s square. The cosine pi over 6 is square root of 3 over 2. Therefore, dA over dt is equal s times s square times 1 times square root of 3, then s square root of 3. 4 times 2 is 8. That means B is a correct answer. Here we reach the end of the lesson. Please do not forget to subscribe the page and share it with your friends so that everyone will benefit and get each new video. Write your comment and press the like button. Thank you for watching and goodbye.